Welcome back to Physics with Miyoshi. This time we're going to talk a little bit more about Newton's three laws of motion. And the first law today is a body constantly in motion tends to stay in motion unless acted upon by an external force. We can express that in terms of our kinematic equations with when our acceleration is 0, then we have a constant velocity. And again, from kinematics, we can think about this when we think about two-dimensional kinematics. When we have an object moving horizontally, and then it gets a projectile motion, and then it's acted upon by gravity, the horizontal component stays consistent or constant, even though the vertical component changes. That's because the vertical component is acted upon by gravity, the force of gravity, or the horizontal component isn't. It's not acted upon by anything, which is why it stays constant. We can express it, we can talk about this in terms of a couple different things. First of all, inertia is how easy it is to get a body moving, and you know this from your real life. If you ever had to push a car, for instance, you know that a larger car is a lot harder to push than a smaller car. And the way we measure inertia is by mass. And in our SI units, SI stands for, what does it stand for? The System International des Units, which is French, I guess. I don't speak French, but it is French. So SI stands for that. Those units are in kilograms. CGS merely stands for centimeters, grams, and seconds. Those kind of units are the measure of mass is grams. And then we have the British engineering units, which they are the slugs for our mass, and that's abbreviated SL for slugs. Don't ask me why they came up with that. It's a long time ago, so we're not worried about that. But many people confuse mass and weight, and while they are related, and we'll get into that a little bit later, we need to remember that mass and weight are not the same. So when people say, well, how much do you weigh? And you say you're 10 pounds, then that'd be 10 kilograms would be 22 pounds. Well, I really want to say that 1 kilogram weighs 2.2 pounds. So if you had a mass of 10 kilograms, you would weigh 22 pounds. But again, they're not the same. So, and we'll talk about that again some more as we go along. Matter of fact, one of the things I would want you to do is I want you to figure out what your mass would be if indeed 1 kilogram weighs 2.2 pounds. How much mass do you have in kilograms? So again, most people think of that as just a simple conversion, and you can do it as a simple conversion, but remember, mass and weight are different. Okay, so then we have this little thing called inertial frame of reference, and the inertial frame of reference simply means that if I'm in a body that is not accelerating, it has an acceleration of 0, I can't tell whether I'm going at a constant velocity of 10,000 meters per second or if I'm standing still, which is why this little window is sitting here. If I was actually using the magic of TV, so to speak, or doing some fun CG, then you wouldn't be able to really know if this window was closed or if it was open. Then you might be able to tell that I'm moving. But if it's closed, like it is now, and there's no magic going on, then you couldn't tell if I was actually sitting still or moving. If this is a room that is in a house, or if it's a room that's in a constantly moving, constant velocity moving object. Okay, so frame of reference, initial frame of reference is very important. It's one that's not accelerating. Point of view is important because if I'm in a inertial reference frame, then again, I can't tell whether I'm really moving or standing still. And we'll get back to this a little bit later, but on Earth, if I think about where I'm standing now, it's really technically moving because the Earth is technically moving, but it is a close approximation of an inertial reference frame, and that just means, again, that I'm not accelerating. And again, we'll get into that a little later. In a non-inertial reference frame, then if I'm accelerating, then I can, then if I look at something else, if I observe something that's in an inertial reference frame from a non-inertial reference frame, then then Newton's laws may appear to not be working. So this is going to be important. Think about, and all the things we do are going to be from an inertial reference frame. So I really don't think about that too much, but except for the fact that sometimes if you have a non-inertial reference frame, Newton's laws will appear to not be working. Okay? So, Newton's first law. Again, look at the kinematic equation, or the kinematic thoughts. That is, our acceleration is 0. As long as our acceleration is 0, then I have a constant velocity. And that velocity may be 0, or it could be some other velocity that's not changing. And it's again expressed that a body in constant linear motion tends to stay in that same motion unless it's acted upon by an external force. So, remember, imagine that there's a constant scene going by at a constant motion, and you'll see that you'll remember that whether I have, as long as I'm not accelerating, it doesn't matter whether it's a constant velocity or a velocity of 0, which is constant also. That's still following. That's really an application of Newton's first law. So, thanks for tuning in, and thanks for tuning in to Physics with Miyoshi. We'll see you next time.